Hello everyone, welcome to Master the Codes. Hope you are doing well. And today we are going to solve another question related to graphs data structure. All those who want to check out more such related content, you can go to the playlist by clicking on the top right. I have provided the link in the description down below as well. Also, please like, share, and subscribe to the channel to stay notified about upcoming videos and more such related content. So without wait, let us get. Here is the question which we are going to solve today. If you wish, you can try the question by solving it yourselves or follow the procedure which I'm going to show you in the video to understand it much more better. And here are the test cases for the same as well. And now let us get started about how to exactly solve this. Okay, so now let's read the question paragraph by paragraph and try to understand what the question is saying. Alice and Bob are playing chess, okay, on a huge chessboard with dimensions of n by n. The first thing that we need to notice is the dimension of n by n, right? Alice has a single piece left, a queen located at this particular position, right? We have the dimensions n by n and the queen located at this particular position, while Bob has only the king standing at this particular position. These are the x and y coordinate. This is the x coordinate, this is the y coordinate. Similarly, this is the x coordinate and this is the y coordinate. Alice thinks that her queen is dominating in the chessboard and victory is hers. Okay, so if I look over here, I have this data, I have this data, I have this data. Okay, let's write it down here. I have a n by n chessboard, right? I have n by n chessboard. I have a of x, a of y, that are the queen coordinates. I have b of x, b of y, that are the king coordinates. I have c of x and c of y, that are the coordinates that need to be given in the question. Now if you look over here, Bob has made a devious plan to seize the victory. He needs to march his king to cx and cy, okay, in order to claim the victory for himself. As Alice is distracted by her sense of superiority, she no longer moves any pieces around and it's only Bob who makes any turns. Okay, so let's try to imagine it. Okay, let's try to imagine it. If I have, let's say, a chessboard like this, I'm not going to draw a big chessboard, I'm drawing a simple condition only. And let's assume the queen is here, the king is here, and the target is here. Okay, now next thing what it is saying, we have this particular condition as well. Bob will win if he can move his king from these coordinates to this coordinate without ever getting in check. And remember that a king can only move to any of the 8 squares. A king is in check if it is on the same rank, same file, or the same diagonal. Then the main thing we want to do is find whether Bob can win or not. This is the condition that we are looking for. Find whether Bob can win or not. And what all things that are provided to us are this, and without ever getting in check. Without ever getting check. Now, assuming this. If I have this particular condition, the queen can give check over here, 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 and this way, right? These are the 8 points or the diagonals, the verticals and the horizontals where the queen can provide us a check. So the king wants to reach to the target without getting checked. That is our condition. And if king gets checked, then Alice wins. Right? Then Alice wins. So that is what we need to do in this particular question. Okay, now let us first see what are the inputs. The first line contains a single integer n, the dimensions of the chessboard. The second line contains two integers ax and ay. Then the third line contains two integers bx and by, and the fourth line contains two integers cx and cy. Okay, so what all things are given? We are given an n, we are given ax and ay, we are given bx and by, and we are given cx and cy. It is guaranteed that the Bob's king is currently not in check and the target location is not in check either. This is another condition that is given. So it is not like as soon as you start playing you are gonna lose. No, the king is not in check in the starting. Furthermore, the king is not located on the same square as that the queen. Okay, and the target does not coincide with the queen's position either, nor with the king's position. That is, if I say the inputs, if I try to evaluate these inputs, what I'm getting is ax comma ay, that is the queen coordinates, are not equal to the king's coordinates, that are bx and by, and they both are not equal to the target's coordinates cx and cy, and the value of n is less than equal to 1000, or n is less than or equal to 10 to the power 3. That is one condition given to us. Now let's see what are the values of ax, ay and by. They all lie within the constraints of n, right? They all lie within the constraints of n. So if I look at it, a, all a's, ax, ay, bx, by, cx, cy, they are all at least less than or equal to n. They do not exceed n, so they are all less than or equal to 10 to the power 3. Now this is what the input constraints say. So the value of n is 10 to the power 3, and ax and by and cx, cy, they all lie within 10 to the power 3. Upon to the intuition. Right, now let us try to solve this question. Now there are a few things that need to come into your mind. What is the type of graph that you need to do, and will it contain a cycle? Now if you look at this test case, this is your graph, right? I'm gonna reduce the size a bit. Yeah, this is the graph, and if your king is over here, or rather your king is here, the king can move to this particular square or this particular square. It will not move to any of these or any of these, because it will get a check. So the best way is to move over here, from here, and then to here, right? So it is, you can say, a directed graph. The king has specified directions in which he will move, and it might contain a cycle, because if you go like this, you will come back to the same place where you started. So it will contain a cycle, right? It is a directed graph. It is a directed graph with cycles. So now, what will the brute force approach be? If I am given this particular, you can say, a chessboard. If I am given this chessboard, then how many are 1 2 3 4 5 6, so I need to create 2 columns extra, right? If I have this particular chessboard and I have my queen over here, which can attack in these particular positions, and I have my king over here, and here is my target. Now we can use either a DFS or a BFS. We can use any of this. What is the main thing that we want to do? From this particular index that is given, bx and by, what we will do, we have four directions. If I say mathematically, one is minus 1 0, one is 1 0, another one is 0 minus 1, and then I have 0 and 1. Now if I have x and y, if I use this particular direction, what I will get, I'll get minus 1 and 0. That is, the value of x will decrease by minus 1. So if I say the king will move down, this is for down, right? And since it will increase the value by plus 1, this is for up. Similarly, this will move towards left and this will move towards right, right? So that is how it will work. So all you need to do, you need to set up these cardinal directions, and actually there are four, there can be eight, like, right, there can be more variations as well. Other than this, what you need to do, you need to have minus 1, then minus 1 1, then I have 1 minus 1, then I have minus 1, and so on and so forth. Overall you will have 8 directions, right? So that is how the brute force approach will work. Now since I'm traversing, which algorithm will work, whether I need a BFS or whether I need a DFS, which one will do the work for me? You can choose either of them, but BFS is preferred over here. Why? The reason being, assume if you have a place where king, the target was just a few steps away, right? The target was few steps away, but you explored entire space, you explored the entire space in different direction, in a different direction. So then it would result in extra complexity or in extra time. So that is why moving small steps in every direction is the best way for us to reach to a goal, right? Now the main thing that comes to mind, that should come into your mind, at what particular point we can fail, right? If I see at what particular point we can fail, that is, let me just draw this, yeah. And if I have my queen over here, she will attack these 8 directions. Now these directions you cannot move. Assume your king is over here and your target is over here, right? You cannot move to this square, you cannot move to this square, you cannot move here, you cannot move here. The only thing is you can move over here, and from then you cannot move here, you cannot move here. Your king will get checked at least once. Your king will get checked at least once. At least once. Right? Now what to do? So if you look at more mathematically, the diagonals are not an issue, right? If I try to draw this particular subspace over here, then what it will look like? It is looking like this, where these two squares you cannot move and king is over here, but you can definitely move over here. You know, it is like you can jump across the diagonal. You can jump across the diagonal. Now, but can you jump across the rows? Can you jump across the rows or columns? The answer is no. You cannot jump. So the main, you can say, bottleneck condition over here is the rows and columns. If you have a look at them, basically, let's see, if you have your king over here, right? You cannot reach these squares and these squares anyway, in any case, right? In any case you cannot reach these squares. So if you have a target over here or over here or any other place, you cannot reach. It will always return in a false condition. Now this is the intuition for the optimization. If you can develop the intuition further, way to go. Otherwise, let's move to the optimizations now. Now, as you can see, I have explained in the previous test case, this particular test case. So what you need to do actually, so if you can, what you're provided, you're providing the coordinates, right? Bx and by, and then you're provided the coordinates cx and cy as well. So if you have this queen, right? If you have this queen, and this queen is dividing your chessboard into quadrants, remember, this queen is dividing your chessboard into quadrants, right? You can call this as quadrant q1, you can call this as quadrant q2, similarly q3 and q4, just like in maths, right? And if your king and target have the same quadrants, have the same quadrants, then it is always possible for king to move. Always possible to win. Now, if I have a look at this particular test case, as you can see, your king and target are in the same quadrant. You can win. Your king and target are in different quadrant, you cannot win. Similarly, your king and target are in different quadrant, you cannot win. So this simplifies the approach much further. So that is how you need to optimize. If just a simple mathematical logic will do the part, right? Now what we have time and space complexities. If now let us discuss time and space complexities for both. If you have a brute force approach, right? If you have a brute force approach, and if I'm taking optimized, now if I'm having brute force approach, I will be using BFS or DFS, in which I have to explore the entire state, right? I have to explore the entire state. So that means I will be exploring n blocks or n, you can say, squares. The time complexity in that particular case would be order of n. And since I'm using either a queue or a stack, the space complexity, I should say, the space complexity would be order of n, or rather n square. The time complexity will be n square because you are traversing n rows and n columns, and similarly you are traversing the entire blocks you are getting storing in the queue, so you are getting the space complexity of order of n square as well. So if I say in actual numbers, it would be around 10 to the power 6, and similarly 10 to the power 6, because it is 10 to the power 3 square, and it is also 10 to the power 3 square. If I'm talking about optimized, you're simply checking if they are in quadrants or not, right? You're simply checking. You are just checking the quadrants of each of not each, rather the king and the target, right? So then what you are doing, you're getting the time complexity in this particular case as order of 1, because you are doing just one. You would need to do simply an if else, nothing else. You would be doing just an if else statement and nothing else. And similarly, if you're using an if else statement, you don't need to do store them anywhere, or even if you're storing them, you would get a time complexity of order of 1 over here. So this is how you will be able to reduce it to optimized. And this is your optimized approach, and this is your brute force approach that I'm giving me the answer of order of n square and the space complexity of order of n square, right? This is my brute force. So now we will be going to the codes, but before that, please like, share, subscribe to the channel and hit the bell icon for more notifications. So here is the question that I wanted to explain to you. I have taken Q, K, and T as the string because I will be taking the inputs in this particular format, right? That is 4, 4, 1, 3, two integers separated by a white space. So I would need to use next line to allow in strings to have an empty space or a white space as well. And then I'm parsing, or rather converting, string to integer. This all 8 are, or rather these are the coordinates: q1 and q2 for queen, k1 and k2 for king, t1 and t2 for target. And then I'm just checking if king can reach the target, and if it can reach, I'm printing yes, otherwise I'm printing no. That is the output I want, either yes or either a no. Now coming to this particular function, I am passing all these 6 coordinates, right? I'm saying get the quadrant of king, get the quadrant of target, right? Now what I'm doing, I'm just using an if else. If a1 and a2, whether it be king or queen or target, I don't matter, because queen is the center point on which that quadrants are split, right? Because queen would be attacking vertically and horizontally, so queen is the center point on which the targets are split, or rather the chessboard is split into quadrants. So if a1 and a2 are both less than q, right, that is they are at the left bottom, then I'm reaching quadrant 4. Similarly, if they are at top left, I'm going 1. If they are at top right, I'm going 2. And if they are at bottom right, I'm going 3. If nothing of this is happening, right, then I'm returning -1, just as a base case. If nothing is out of there, something out of there extraordinary happens in any test case, so I'm just, for the safe keep, I'm returning -1. Now, if king quadrant and target quadrant are equal and king is not in currently check, I'm returning true. Otherwise, I'm returning false, as explained in the logic, if king and target are not in the same quadrant. Now, if I copy this particular test case and run it, I should be getting the output as yes. I'm getting yes. If I run the next test case, I'll be getting the output as no. And if I run the last test case, I would be getting the output as no, right? So that is all for today. I will be sharing this particular code with you along with the link of the question in the description down below. Please do not forget to like, share, subscribe to the channel. and be notified for the latest updates. Until then, bye bye.